Telecom WPC division to join me on the dais. So now moving on, the first technical session talk is by Mr. Avinash Agarwal from Department of Telecoms. A brief bio. So he's an officer of the 1992 batch and he has 31 years of experience in telecom, information technology, and broadcasting while serving in various positions. So he was also from 2021 to 2024. He was the DDG at Telecommunication Engineering Center, which is the standard setting organization for telecommunications, where he was in charge of standardization and convergence and broadcasting divisions. He was also involved in framing the policies and test procedures for emerging technologies like the trustworthy artificial intelligence and broadcasting equipment. And he was also earlier at Prasar Bharati, where he looked after transformative initiatives for Doordarshan and All India Radio. He was also involved in rollout of Bharatnet project for providing optical fiber connectivity to Gram Panchayats. He currently the Vice Chair of ITUR Study Group 5 on terrestrial services and Vice Chair of ITUT Study Group 21 on multimedia content delivery and cable TV. So I now invite Mr. Avinash Agarwal to the dais to deliver his talk. I would request also the speakers to limit themselves to 20 minutes due to the tight schedule. Thank you.
Thank you. Good morning. Can we have the presentation, please? So, if we can make it full screen. So, because I have a limited time, so I was wondering like whether I should talk on one topic or multiple topics. But then I thought that it's better to focus on just one topic, which is fairness assessment in artificial intelligence. Next, please. So, because a limited time is there, I will not go into the details. Just cover like we all are aware of the importance of fairness in AI and what could be the sources of bias. So, just for a recap, the bias could come there through the training data sets or through the algorithms used in the learning process of the AI model, or even during the uses, like if we are using the model and it is learning while being used, then the biases might crop in. And then the biases could be on the demographic attributes, which could be like age, gender, marital status, race, and all those things, which are very commonly discussed. But this could be also in other attributes like temperature, time, and these are very important for the telecom scenario.
Recording in progress.
So these are very important for our scenario, because when we are talking of autonomous decision making or IoT or smart cities, then more than the demographic attributes, these other attributes could be very important. So if the decisions of AI are inadvertently being taken on these parameters, these could impact the decisions. Next, please. So how to measure the bias or fairness in an AI model or the data set? So there are lots of matrices available. I've just listed 4 of them. Like there are demographic parities. These are just like measuring the probability of any favorable outcome for the privileged class and the unprivileged class. So I will not go into the details because the time is limited, but lots of fairness matrices are available. These 4 or 5 are the popular ones, but if we visit the site of IBM Fairness 360, then they list around 80 such fairness matrices. Next, please. So we did some study. Unfortunately, perhaps many of you may not be able to read this thing, but some time back, like the reference is also mentioned at the bottom. So 3 years back, we did some study on the limitations of these fairness matrices. So for each data set, these are the popular common data sets like German credit data set or health insurance cross-sell predict data set and others. So we use these data sets, and first we found that whether the data set itself is having bias or are fair. And then we trained AI models, and then the outcomes were checked whether the outcomes are fair or biased. So we use 2 fairness matrices for the data set, incoming data set, and 3 matrices like so like we used 2 matrices for the training data set and 3 for the outcomes, and then we plotted them like this. Band is kind of a tolerance band, like 100% accuracy will not be there, but suppose we say we accept for plus minus 5%, so 10% variation is acceptable. So anything outside this band could be considered as a bias. So we use 2 matrices, like the first one, this one, like DI and SPD for the incoming data set, and 3 for the outcomes after training the model. And so these are the observations that like a single metric may not be correctly identifying bias in all the metrics. Different metrics might be required for different uh, kinds of data sets. Different metrics might be required for the incoming and the trained data sets and all those things. So uh, if we see like just this example, here one metric shows that there is no bias, but the other metric shows that there is lot of bias. So using a single metric may not be a reliable thing. So we need multiple matrices. Uh, Next, please. Next slide. Or I can do it from here. Sorry. Sorry, I can do it from here also. So this is the same data which is like presented in a tabular format. So our concerns were like if we are using multiple protected attributes, like in UCI adult datasets we had 3 attributes: race, gender, and marital status, and then we are using say 2 for inputs and 3 for the trained model. So now we have 15 values. Now how to identify, looking at these 15 values, that the model is fair or biased? So we need a single value which can give us some overall idea, and this is a very simple case. In practical there may be say 5 or 6 protected attributes, and we were using multiple matrices for them. So perhaps we might be having something like 20 or 25 individual values. So what we did was we combined them into two new matrices. One is bias index, another is fairness score. So these two were proposed by us in our paper in this. And bias index gives the fairness value of bias of that particular attribute. And fairness score is the combination of all the bias indices of all the protected attributes and the overall bias in the application. So uh, this is the formula that we have used, that this is the bias index and this is the fairness score. So the idea of discussing this is that like when the focus group is meeting and developing the terminology, perhaps I would request the experts here to include the definitions of the combining metrics also in their terminology, because most of the times we are looking at the individual fairness matrices or the group fairness matrices, but are often ignoring the combined matrices. And this is already like involved giving an overall picture. So I would request that these terms like bias index, fairness score, these are also included in the terminology that you are developing. So based on the work that we did, we got a lot of positive feedback that why not convert this into an standard assessment process. And so TEC initiated this work in 2022, and with lot of consultations we could evolve this fairness assessment and rating of artificial intelligence systems. So now it is available, and in fact we have created one IEEE PAR also, and now we have already signed an adoption agreement with IEEE, and the process of its adoption by IEEE is in progress. So this is the process, especially for our friends from outside the country, that we follow a very transparent and exhaustive process of consultation. So we started like this was the paper that we discussed, but then we had one round of consultation, then we a webinar, open house, then a group of experts from industry and different ministries was constituted. These experts drafted the first cut of the standard. Then the draft recommendations were put on public website. Again, second round of consultations was there. Then again, the experts revised the draft, and then the experts of TEC through DCC and sub DCC, they finalized the draft, and then finally it was released by secretary because it was considered a very important work. So this standard follows this three-step process. Like the very first step is to have a risk assessment, and we are very happy to say that like we mentioned about the 4 levels of risk in our standard, and subsequently like the similar 4 levels were also articulated in the EU AI Act also. So we are not saying like they copied us, but like we all were thinking on the same lines at the same time. So we also have this graded risk assessment in our standard, and this is what the international community is also following. Because same treatment cannot be given to all the AI models. Something which is critical has to be treated in one manner, and which is less critical can be dealt in a different manner. So the very first is the risk assessment, for which we have provided in our standard self-assessment questionnaire, which the developer and the auditor both should sit together and develop, and then find out what is the risk profiling of this particular application. Next is to determine the thresholds, benchmarks, and for bias testing. So like as I mentioned in my graph, like we had used plus minus 5%, but in some cases we can say that I can have a tolerance of 20% or a tolerance of 25%, but in some critical cases we may say that I cannot accept bias more than 2% or 5%. So all those thresholds and benchmarks have to be determined in the second step. And then the actual testing will start, and it will cover the process, the metric, and the scenario testing and other things also. So I have given a very high-level overview, because I was given just 15 minutes, so time is less. We have also covered 6 dimensions in the standard. Like it is not just the data, but even the entire scenario, like even the life cycle stages, the application, different kinds of modalities, data modalities, the ML model kinds, all those 6 dimensions are covered in the standard. And then this is the next step. Like the standard was developed for supervised learning model and for tabular data, but now as we move forward, new developments are taking place. We have lots of image data. We also have unstructured text, which could be like generated through logs of the telecom network, or it could be through social media and other places. And then we also have generative AI. So for that also we did some work and published a paper where we mentioned about how we can augment this standard to take care of these new emerging challenges, because many times the data that we are using is not just tabular. It could be image, it could be unstructured text, or it could be through generative AI. So these are some of the points that we have mentioned, and we are perhaps working, and I'm sure my friends in TEC are taking up. We are evolving this into a new version of the standard, where all these points we would like to incorporate, so that we are able to take care of image, unstructured text, and LLMs also. So I think this is all. These are some of the references that I have mentioned, and thank you very much. If there are any questions, I am very happy to take these questions.
Recently, there was a news that ChatGPT is, there was a hallucination policy. So is it related to this fairness thing, or is it something which is inherent in the AI models?
Sir, it is a mix of all. Like hallucination also is a result of some bias in the model, because the model has certain preferences which it provides without cross-checking the fact. So, but it is not just bias, it is like a flaw in the model, or it is a flaw in the prompt itself. Like if you give the prompt properly, that don't hallucinate or don't give hypothetical outputs, then perhaps the outcome will be there. So like in LLMs, the prompt is also very critical. But yes, sir, it is to some extent related to bias.
There are graph actually which is checking the fairness of the data model. So whatever the for AI models will be check the fairness, that can also be biased. So how to take care of that? That you are looking for any particular framework which should define these models how to work.
So we are not using any automated tool to assess the bias. That's why we have this three-step process where we first of all identify the risk profile of that. Like if it is something very casual, like maybe some kind of a chatbot, then perhaps we have a different criteria. If it is something which is used in like autonomous car or in some IoT sensor somewhere, like where autonomous decision making is there, perhaps we have a different criteria. So first is that. So it is very important that the developers and the auditors sit together, talk to each other, understand what is the application, and then move forward. I have removed lots of slides because where I discussed exactly the same point, that fairness itself could be biased. Like if we talk of fairness, it has to be very context dependent. So same application being used in India and same application being used in your country, the definition of fairness could be different. So it has to be very much context dependent.
In the process of the standards development, I think it's very important to look into the ethical non-ethical practices, number one. Number two, up to what extent is taking away the conventional job perspectives. And I mean, see, there may be a day where everything goes into automated mode, etc. There may be some context which people do not have many of the employment opportunities. So I think whether we have devised any such standardization or any method like that, if not, when will it be developed?
Thank you, sir. So, like, this is a very important, pertinent question. So, TRI came up with one recommendation in 2023 where they talked of these ethical principles. They basically copied from OECD. There's this fairness, accountability, explainability, sustainability, and robustness. So, these five principles they mentioned, which are like the ethical principles. And then we ourselves have done some work on AI incident reporting, like if something happens, some harm happens, or to the public also, or to the network, to the governments also, then there should be reported in a structured manner. And I think one draft standard has been circulated by C&B division on standardizing the standardizing the template or schema of the AI incident reporting. So, sir, these are some of the initial steps being taken. But you rightly mentioned that we have to have some uh, guidelines for ethical use of AI. But this is also a dilemma, like where to draw the line between regulation and self-governance. So that is something there, sir. Thank you very much. Thank you.
Thank you, sir, for an insightful presentation. Now I would like to invite Ms. M. Revati, Joint Wireless Advisor, for her talk. Before that, I give just a short biodata. So, Revati Madam joined the Wireless Planning and Coordination Wing as a Group A officer in '96, and then she has been she has represented she has represented as a frequency expert from Asia Pacific region, the Frequency Working Party of the International Telecommunication Satellite Organization, with its headquarters in USA. And she has also assisted Department of State as a spectrum regulatory expert in dealing with international arbitration cases at the International Court of Justice in Hague. She has also contributed and attended various meetings on spectrum management at the ITU level and also at the APT level. And she has experience in radio frequency interference resolutions and spectrum auctions, and her present portfolio is as head of the satellite section, looking after all the issues related to management of satellite spectrum, notification and coordination for orbital slots at the ITU in coordination with the other countries. So now I invite Revati Madam for her talk. Thank you.
Thank you, Ranjana. so the height is a little difficult for me. So very good morning to all the distinguished participants who are physically present here. Also, very good morning and good afternoon, good evening to all the virtual participants. And my topic is, though I don't know much about AI, but I'm seeing a lot of uses of AI in the spectrum management. So I try to bring into the spectrum management where we really need AI, and some people started using, and I see a lot of use cases there. So the first, if you see the tag word, AI will make radio communication smarter. Radio communication will enable AI functioning and connectivity. It is not my word, it is the ITU word when they talk about radio communication. So AI will make radio communication smarter. So AI will help, sorry. Thank you, so nice, Asa. So I think I am comfortable now. So AI will make radio communication smarter. So if we see the first top, there are all the various applications. They all need spectrum. Most of the applications need spectrum. And usable spectrum, though the spectrum is very wide, usable spectrum is limited because your ecosystem, equipments are available. The same spectrum, the same pie of the cake, everyone wants it. So how we can do it? We can do using the AI models. Deep learning models, we have a database, we have experiences. Train the models so that we can efficiently utilize the spectrum. The end result is optimum spectrum utilization management strategy. RF spectrum for, we have a G2D, we have a terrestrial, non-terrestrial network integration, we have a LEO communication, I'll come to that later. Then we have a milliwave spectrum, millimeter wave spectrum. It is predominantly used by the satellite and also used by the 5G, 6G now. How we are going to dynamically sharing and using that spectrum? AI will help. Then terahertz spectrum, of course visible light, we are not controlling now. ITR doesn't control visible light. Probably in the future we'll control that. So these are the things. So then I'm just trying to link with where is that radio communication sector plays a major role. ICT plays a major role in the sustainable development goals. And ICT is what is that? Latest technologies, Industry 4.0, Internet of Things, connected cars, intelligent transport systems. They are all depending on the telecommunication network, services and applications. They in turn depend on the radio communication sector for ubiquitous connectivity. You cannot have wireline connectivity everywhere. You need wireless. So there the radio communication sector is a major component in this entire ecosystem. So what is that radio communication sector? Spectrum as well as satellite orbit resources. When I say satellite orbit resources, that is orbit come with a spectrum. And the satellite orbit resources is managed by the ITU because it is an international subject. It's not national like terrestrial spectrum. So then globally, harmonized regulations and harmonized standards, that is very, very important. So once the spectrum is identified, then these things will come into play. So this is the interplay of the entire ecosystem. So artificial intelligence acts as an enabler to enhance emerging radio technologies. Fundamental raw material is the radio frequency spectrum. The second, the key developments in AI for spectrum management. Few of things I think we are already using, but to the limited extent. When I say the dynamic spectrum allocation, AI will enable the spectrum among the resources, users, depending on the congestion and the demand. That is already happening in the 5G. And it is inbuilt into the 6G. But when I talk about spectrum, this 5G, 6G spectrum is also used by the government users. It is also used by the satellites. And satellites for different purposes, communication purposes, navigational purposes, earth exploration purposes. There we'll be using this technology. We have practical cases in India. The same spectrum we are using between our NAVIC system, that is the Indian Regional Positional System, and the 5G. So we have a keep of distances, we have challenges, and we see AI will help in that, so that both can. Then interference mitigation. So you all know that advanced AI algorithms mitigate interference between the users of services sharing the same spectrum. When we go to 6G, there it's the concept is already the same spectrum is shared by the multiple applications. So then people can think, what is great thing about it? We are also now sharing. We are sharing among between one mobile service and another fixed service. That means fixed service means I know that it will be here in Vigyan Bhavan, it will be in Sanchar Bhavan. So I can statically identify the exclusions. But in the 60, what is coming is, this is also mobile, that is also mobile. I'll be not knowing statically. It is dynamically, it is shared, the same spectrum is shared. In that case, this interference mitigation is very, very crucial, especially when there are safety services, when there are public services where you have to maintain quality of service. So that is possible with all your help. You'll be developing AI models which will help us in improving the spectrum management. Then next is cognitive radio network. It is a very old topic, but it is a heart of all this spectrum management. Cognitive radio network, it is dynamically, it will be selecting in the particular area, that particular spectrum is being used by them, at what level, those things, and it is sensed and it can be put into alternate use. Switch to the best frequencies. The last one is spectrum sharing optimization. See, now the era has gone. Earlier we used to band segment the spectrum for commercial use and the government use. Generally in the US they call federal, non-federal use. In the India we use it as a strategic use or government use and commercial use. Now there is no that static divide. You need to dynamically using it. Like in some cases what they do, suppose some government entity using the spectrum in some coastal area, whenever some ships comes only they use. So it will be detecting whenever ship is not coming, it will be put into other use. Whenever the ship is coming, they know, they plan it, it will be vacated and given for the government users. That is the way. So now in the current era of convergence between terrestrial and non-terrestrial network, see, now every day everyone is talking about direct to device. So now this phone so far we are receiving from only our BTS. When we go out of, let us say, go to Himalayas, Ladakh, we don't have terrestrial network. And I cannot carry satellite phone to have a communication there. Now the thing is, this phone will receive from the satellite also. That we call in the ITU parlance, it is direct to device. That means same IMT spectrum you are putting in the satellite. So how to ensure interference-free operation and how to ensure you should not cause interference to your neighboring countries, because satellite is an international topic. So AI will help me in that. There are developing the algorithms, how it will detect and how it will cause. So in the current era of convergence between terrestrial and non-terrestrial network, adoption of AI into spectrum management is an immediate necessity. It is the necessity. So some of the examples I just try to show how AI will help. The first one is the AI-enabled propagation models. When we do any spectrum management, propagation model is the fundamental thing. So then only I'll be able to tell this signal can go up to this, afterwards I can use the other signal, other user. And this propagation varies with the season, date, time and terrain. And we have more or less static models. Now people started working on the AI-based propagation models. That is the fundamental principle to make efficient utilization of the spectrum. One simple example I try to show you. In certain period of time, the distance between two services without interference is quite large. If you go to the other side, the distance has reduced within the day. It varies in the season also. So that if you model based on the AI, we'll be able to utilize the spectrum and we'll be able to put more users in the same area. The other side is a cognitive radio network. That's what exactly I explained. The primary, whenever I say PE is the primary user, another is SE is the secondary user. There will be sensors, there will be sensing, and there are some quality of issues can come, but secondary user can take that risk. So primary user, we will not cause interference. These are the users and we'll be using, there are some applications and these applications will grow. So then my pet subject is a satellite, and everyone knows now satellite has become so complex with the LEOs and all. So this AI, already satellite operators started using AI to limited extent in the satellite maneuvering and handover and anti-collision. But there is a long way to go, and probably we'll be using in a bigger way in the satellite communication. So AI for satellite communication, if we take, because it's a big topic, I try to focus on the fundamentals of it. The first one is beam hopping. If you take LEO satellites, there will be a lot of beams. Within 2 hours, they'll be moving. And the hopping also, they will not be putting every static beams. Because wherever it is passing through, let us say, Rajasthan desert, it need not radiate there. They do beam hopping, they do beam shaping, they beam switching also. Because satellite energy saving is very, very important. My satellite life depends on the satellite fuel there. So, beam hopping, energy managing, then telemetry mining. I have multiples of satellites. Currently, I think Starlink is having around 7,000 satellites. They have filed for 75,000 satellites. I need a health of all the satellites. That telemetry also through artificial intelligence only I can do. Gone are the days we used to do with certain sort of intelligence at Earth for the GSO satellites. For the LEO, it's impossible to manage. So then traffic forecasting, like how many users are linked to each beam and what is the data rate they are going to us. Accordingly, I have to divert my spectrum resources there. I'll be reusing that spectrum. So that forecasting and modeling, then interference managing. When we talk about LEO satellites especially, they share the same spectrum with the GSO satellites. The satellite spectrum is highly shareable. So when they come in line, continuously you have to calculate, you have to switch over the frequencies. Otherwise, you will be causing interference. So this interference managing is very critical, especially in the LEO communications. They get less priority compared to GSO. Then space to air ground integration, because they should have proper link calculation also. When you are using in the KU and KA bands, they are highly spot beams. Exactly they have to steer so that they will have a high throughput with a proper quality of service. These are all possible with integration of AI into this. So that's what I just try to summarize there. Reshaping global broadband and IoT access, demanding robust system architecture. Challenges, network complexity. Of course, latency is critical. We want it, that's why we are going for LEO. And resource management. Resource management is especially that spectrum and beam shaping and beam forming. Then AI enables. AI will definitely help in that. This one I just, how it is going to do. I just took only LEO satellites. They have a LEO satellites, they are interconnected satellites. There will be continuous handshake. And they should be continuously talk among themselves. And sometimes they take their own decisions based on the training of the models. Because we don't have time from here ground to control them. So, quickly changing environments, minimizing signal loss and maintaining connectivity. And also network optimization using dynamically route traffic and manage systems. Because suppose you are linking to one satellite here, there is a GSO satellite also. You should not cause interference to GSO. There will be 3-4 satellites. So you automatically sense and route it to other, because user should not feel that his data rate is going down. Whereas satellite automatically will be switching and routing it. Then similarly, frequencies based on the real-time demand and interference conditions. Adaptive modulation and coding. Signal parameters to maximize the throughput, and finally reshape the beams for optimal coverage and efficiency. Then slightly I'm just going above. It is only LEO I talked. What is artificial intelligence in the space? Now the buzzword, even the ITU, UN has taken cognizance of this. It's sustainability is not only Earth and the sky, it is the space sustainability, complete. The space debris, space situational awareness. So now the concept has come, like autonomous satellite operations, they devise themselves, and in-orbit servicing. So you go there and the satellites will be serviced then and there, and satellite refilling. The fuel has gone, it is, and you will be going to, that is a moon, and you are going to other deep space missions, like Chandrayaan, not Chandrayaan, what is that, Adityan, your Mars, Venus. They go, they refuel within the space itself, and the probe will go further. These are all the use cases where, and space tourism, where it is possible only we can achieve with the help of AI, because earlier we have only limited missions. Now it's completely polluted. Many are there. That is one space situational awareness. I've just taken one snap of it. These are so many satellites surrounding our Earth. A satellite debris, satellite, so many things. Now there is a NORAD, one agency, they map, because it is required. They'll be moving. They can damage our satellites, operational satellites. So how to remove them? And if you map them and you map everything, at least with AI will help you. In advance, you have to maneuver. You have to deorient, you have to shift slightly to protect yourself. That is, even International Space Station, they do that, and AI is going to do a lot in this. Then space debris removal and all. So AI for collision avoidance, space situational awareness, integrating sensor data using AI for real-time mapping of the orbital environment. Then deorbit and end of life. Now, ITS has taken a decision, even UN WUSA, that any satellite going into the space, you have to commit that after end of the life, whether you are bringing it down to atmosphere, if it is a GSO, putting into the graveyard. Now, AI is part of it, and AI will be deciding at what time it has to go to graveyard or it has to go to, because it should have some fuel, then only it can be maneuvered. Then finally, the regulatory and spectrum compliance. Where is that we want it? See, when we made any filings, satellite filings to ITU, ITU examines that. So this AI-based examination will help at ITU, BR, it is the secretariat for all satellite filings, national administrations, because it files to national administrations, and satellite operators. Where it is required, when I file ITU, we have to tell these are this is my constellation, and this constellation is going to affect, these are the satellites which I will be coordinating. These all things can be possible when I am doing for 75,000 satellites. Humanly it is not possible, even existing algorithms it is not possible. The AI only has to come and help us. Similarly, regulatory compliance analysis. Then they say which satellite I am going to affect, or which satellites, which particular satellite system is going to affect our satellites. That analysis, we have visualized and all some software. Still, it is under development, further improvements. So I think that will help there. Another last one is interference resolution. Triangulation, because within it is a terrestrial interference, it is little easy, it is in your territory, you know it. If it is coming from the satellite, you don't know, it's very difficult. We have a triangulation method. And with GSO, it was a little successful. Now with LEO, so many things. AI has to come and play a part. So I see a lot of AI usages. Without AI, probably future spectrum management, we cannot even imagine. With that, I hope I have not taken, I completed in my time. And for any questions, I'm open.
I have one general question. It is related to not satellite. In fact,
Yeah, please.
we are giving so much of power to AI. It is taking decisions itself. Earlier it was command and autonomous type of thing. Now, do we have in future also? Do you have we thought of about having so much of control that AI is not doesn't malfunction, or it is some virus or something is there, and in that case it may play havoc because you are giving power to AI in satellite case or other cases. So it has to be very foolproof system if we have to allow AI to work in so many critical fields. So anything about that is there in mind?
Yeah, it's a good question. I think AI people will be able to throw more light on it. But now, because you have to take the help of AI. By the time you decide here, suppose two satellites are coming very closely. By the time you decide here and send the command, you don't have time. Havoc will happen. It has to be on-board processing and own intelligence there. But your point, probably people will take care while develop that system. The command from from the ground is really, that is not a solution. Yes, sir.
Want to ask one thing. I think what I understood basically it's more a use case of the AI, and so far you talked about the DSA. These are actually in practice. It is working now. I mean, one of the band, the full band, when you work for the web searching and something like that, it goes into a lower band. If you want to do some gaming, etc., automatically it takes you to a higher band of the frequency. So this type of DSA things are already working. It's in practice.
Yes, sir.
And the important thing, what I want to know here, I mean, it's very fine. AI can be used everywhere, wherever some human intelligence have been there. A sort of replication, you can always do it by AI. Why not only on satellite or orbit or anything, anywhere you can do. My question actually, see, I saw somewhere that orbits now, it's become another scarce resource. And I saw somewhere that possibly, suppose India, now we think of doing something around 50,000 satellites in the form of LEO or MEO. If we want to put it into the space, then possibly there may be a shortage of the orbits, and the ITU may not be in a condition to do that. The advice that was given that India may borrow it from some of the orbits that has already been allotted to Russia and some other countries. That means countries like Russia and others and few more, they have already booked spots or the satellite orbits. What India has done, why we had been waiting, why we could not do that? Yeah, that's the
Sir,
question.
thank you, sir. It's very good. Sir, when you file to ITU, when you send a filing to ITU, there are some regulatory timelines. So, India, we have a GSO orbits, whereas in GSO orbits, we have filed and we have some orbits and we have our own satellites operating there. When you file to ITU, within 7 years of that filing, you have to bring the satellite there and make it operational. Otherwise, you will be losing the priority. For the GSO, we are in that place, okay. And there is in the case of GSO, there is well established regulations. That means even the countries which they come later, they have some planned band. That one orbit is reserved for each country because people will not go and hold all the spectrum. It is not on first come, first served only, certain portion is reserved. In the case of NGSO, it is not the case. Still regulations are developing, people are filing it. Now in the WRC 27, for the new bands, this concept has brought. The country should not be deprived of. So when come to India's point, even if India, if we can go and file 15,000 satellites, we should be able to bring into use by, there should be use cases by within 7 years.
What I want to say actually, for example, you might have seen a practice what has already happened.
Yes, sir.
IPv6 that we are moving into.
Yes.
It already happened before we could conceive that a huge number of that
Yes, sir.
physical addresses has been taken away by USA, UK, and other developed
Yes, sir.
countries.
Yes, sir.
And actually, had it not been done in time, IPv6, India would have been one of the sufferers.
Yes.
I'm talking of that. Why that foresightedness not was there with us? If Russia can do, some other country can do, they can book their orbits. Do you think Russia has done everything? As you said, even the norms are not coming.
Yes, sir.
India also should have done that.
No, no,
We
sir.
also should have applied for 50,000 satellites
Yeah,
and
yeah.
booked the slots.
Yeah.
We have not done that.
Yeah, yeah,
Now they're suggesting borrow it from Russia. Why should we borrow?
No, sir. I just take it a little. For the LEO systems, Russia has not filed anything. For the LEO system, it is a Starlink by the US and Norway, and OneWeb is by the UK, and China has also filed LEO communication satellites. We have LEO non-communication satellites. They are of only Earth observation, remote sensing and all. But these 75,000 or 60,000 are of communication satellites. And you are correct, we will become only consumer market, India, if you don't fire. And the most suitable location is 450 kilometers to 700 kilometers. If it is highly crowded, the same spectrum coordination will be difficult. Now, India through InSpace is trying to engage with the industry because it's the satellite operator, which has to build the satellite and put. So I think India is seriously thinking to do it. And when we come to LEO, it is a global market basically. That's point, sir.
Think to that. Now it is thinking.
Yes, sir.
But where the thinking were there 10 years before.
Yeah, exactly,
It should
sir.
have been done when many of the countries they have already reserved. And I was told, you said that Russia is not in LEO. Please check. I was told that enough of the orbits have already been reserved for Russia because they submitted plans. And what happens possibly India or a group, we could have made some groups with UK or some other thing, could have entered into that. Consortiums are possible.
Yeah.
So somewhere this way, that way we could have entered into that we also get scope for reserving some of the orbits.
Exactly.
That I do not find. That
Exactly.
didn't happen in India.
Yes, sir. Actually, as you correctly told, 2014 onwards, that momentum has started, all this LEO explosion. And yeah, I agree with you, sir. India's left behind. I think, thank you.
Thank you, ma'am, for the very enlightening presentation on satellite and use of AI in it. So now I would request Sri Rudranarayan Paley, sir, member designate on the dais, for presentation of mementos to the speakers as a sign, as a token of thanks. First, I would request Shri Avinash Agarwal sir to come forward. I now request Revati ma'am to come forward. Now I would request Avinash sir and Revati ma'am and Shri Rudra Narayan Palai sir to everybody congregate on the dais for a group photo. Sir, a group photo, please. So now we move on to the next part of our session, which is the Buildathon. So I'd request Ms. Preksha to take over now. She'll start with a brief overview of the Buildathon, and then we will move on to the teams and their presentations. Over to you, Preksha.
Good morning, good afternoon, everyone. So, I'll give you a brief overview about Buildathon. Buildathon is a collaborative event with FG-AINN. It is designed to explore, prototype AI native solutions addressing both next generation telecom network requirements and societal challenges. Buildathon is organized into 4 stages. Stage 1, demo proposal. Stage 2, implementation. Stage 3, initial implementation. And stage 4, final demo. Today we will see the final demos of all the teams. We have received 25 contributions, and we have shortlisted 10 teams who will be presenting their demos today. The objective of this Buildathon is to have hands-on learning, prototyping, and implementation process experience, collaborate with industrial, academia, and industrial institute. The most important outcome for this Buildathon is learning. The evaluation criteria for the participants is 1. The aim of the demo proposal should be clear, well-defined, and in relationship with AI native networks. Is the scope of the contribution clearly explained and based on the overall design be focused on specific scenarios for the demo. Criteria 2. Is there a clear mapping between demo scope, functional and non-functional requirements, and demo objectives? Are there practical implementation options and testing options? Evaluation criteria 3. Are the test cases clear and well documented? Evaluation criteria 4. Does the initial implementation show clear progress towards final demo? Evaluation criteria 5. Does the demo show clear mapping of initial design? Are there valuable learnings called out of in the final demo? And each of these 10 points will be scored from 1 to 10. The evaluation will be done out of 50 points. Thank you. Now I will call the teams. The teams, Ranjana, over to you.
So the first team is Aionet, and the participants listed here are Prithvi Krishna, Miss Varsha, and Miss Nilanjana Chakrabarti. So they can come on the dais and then do their presentation.
Good morning, one and all present here. So, I'm Varsha from VIT Chennai, and
I'm Nilanjana from VIT Chennai.
so we are here to present Aionet. It is a lightweight, explainable, and edge-based system that helps in monitoring the traffic. So, imagine we are in a situation where you are a rural doctor and that you're having some a live consulting with patients, but there is some lag in the video. Because and then you later on find that it is because of something some system update or some downloading stuff which goes on in the background. And then this is something which is not because of poor internet alone. This is because of the user end's traffic. So our Aionet, it reduces or it monitors and controls the traffic at the user end so that there is some smooth flow of traffic and there is there is no congestion even at the router end. So over to Nilanjana to explain the database.
Our database is the heart of our system. It is where the feedbacks are logged, the user priorities are logged, and which is again used for the AI for learning. So when the next time then the same app comes, the AI knows what to prioritize it initially. So there are 4 main tables in our database. Our first table is app metrics. The app metrics table stores our app name, the CPU usage, the bandwidth, the priority which is calculated, and the timestamp at which it is stored. The second table is app priorities. It stores the app name, it stores our app name and the initial priority which it was given, and then it stores the overridden priority and the timestamp. Our third table is a feedback table. It stores the app name, the initial priority, the overridden priority, and the timestamp. And the fourth table we store is other unknown apps. So, like for example, sometimes it is not known about the app, like there's no specific port to app mapping, so sometimes an unknown packet might enter that network, and that is logged into this table. So it contains a unique app signature is created for these kind of unknown packets, and that app signature is stored, its first seen and last seen, and the timestamp is stored in this fourth table. Now we'll move on to Varsha for explaining the core logic.
So this Aionet, the core logic is to prioritize the right app traffic at the right time, so that it is actually intent and intent based, that is user based. Later on I'll explain how it is user based. So it is initially app behavioral based. So the first thing what we are doing is we collect packets. we sniff it through SCAPI sniff function, and then each packet at the user's interface, it is grouped into a flow control. So each flow, what is flow in a sense is there is a destination. The PID is actually the source IP address, destination IP, and the port. All they all form a unique key. So this is what is flow. This is what flow is. And then we do the mapping, port mapping, where the PID is mapped to the destination port, and based on this we classify it into known apps and unknown apps. For all those for which we know the PID, it is classified into known, and for all those for what we don't know the destination port, that is classified as an unknown app. So we handle known and unknown apps both separately. This is a plus point of our Aionet. So, and the next thing which we do is the important thing, that is the prioritization. Based on what does the app traffic is controlled, it can't be simply a simple logic like what comes first can go first. Instead, we are prioritizing based on the application behavior. The application behavior is the CPU percentage. Why we are considering CPU percentage is that CPU at times it depicts intense process, it depicts some complexity in the process which is assumed to be some important process. So we have we can't just simply classify it into based on CPU. So we have other types like the packet count and bandwidth, based on which we prioritize everything or each and every packet. So the thing is here, each and every process of the prioritization is done in real time. So we do not have to worry about what if there is some change in the app priority, what if there is a user wants to change the priority. So here we offer another option. So each and every user, it is user independent. Like what I get in my system may not be hers. So each and every user have their get their chance to edit the priority in our dashboard. So they can edit it and they can use it. They can edit it based on their intent, and that is why we call it as a intent-based model. So this is completely non-radio as expected, because non-radio is very it enhances the security, and there is no fear, and it is rule-based. There is no fear of that if there is a bad outcome or something. So the next thing is bandwidth shaping, obviously. So whatever, based on the priority, we shape the bandwidth dynamically. That makes the system traffic efficient and lets the packets in an efficient and orderly manner, so that there is no traffic accumulation at the end. So over to Nilanjana.
So we have all heard about the known apps. What if we want to know about unknown apps, like unknown packets, or like even custom packets? So we have also included an option for sending custom packets to the network. This will be primarily used for security testing and to show how our AI adapts to even these kind of packets, not just known or unknown packets. So in our custom packets, what we do is we use Python SCAPI class, and we extend it, and we add additional subfields to it. So the subfields there are 4 subfields which are added. The first one is a 2-byte integer. The second, the other 3 fields are all fixed data by strings. So this custom packet is sent to the network, and then what our AI Aionet does is it does not just discard them. It logs their app signature, and it again enters into the pipeline of classifying it as either known or unknown apps. Same thing goes on for unknown apps. Sometimes what happens is when there is no port to app mapping, the packets become classified as unknown. So what do we do with those unknown packets? Sometimes they can be malicious also. So what do we do is, again, our Aionet gets an app signature and it logs them into the unknown apps database. And what is also done is there is a security app details section in our dashboard which showcases all these unknown apps. So the user can get to know whether these unknown apps are like unknown packets are like they enable them, or are these malicious? Now we move on to Varsha again for the monitoring aspect.
So before monitoring, I would like to clarify that policy injection. So we also deal with policy injection. So the user, as I already said, user have the right to change the priority. This overridden priority is indeed, as she explained, is indeed stored in the feedback database, and then it is used for future monitoring of the data packets. So now coming to the monitoring part, we have 4 layers in it. The first layer is the application layer, where we calculate the CPU percentage, the bandwidth, and prioritize it based on that. And the second type is a network layer, where we where we capture the packets, find the total number of packets in each application, and then count the find the data number of data the length of the packet. And then this is also involved in the prioritization part. And then later on comes the unknown packet handling, which already she explained. And the next part is a feedback thing, which we already explained. So now let's move on to Nilanjana for the next.
I will be now be showcasing our dashboard. So this is how our dashboard looks. So there are different stages, like different parts of our dashboard. The first part are the applications. So these applications are the currently running applications in the user system. These are refreshed every 2 seconds thanks to the Flask socket IO command which we use. These are refreshed every 2 seconds, and all the app information and metrics are shown. So the CPU, the bandwidth, the priority, which is already calculated, is shown. Now, and we also provided the override. So what now the user can do is, maybe like if they have opened Zoom and Zoom is showing a low priority and they want it to be high, so they can go here, they can click on the override button, and they can go to the drop down and they can make it high, and it will automatically become high, and the bandwidth will be allocated likewise. The second part is the security alerts, like how I discussed while I was discussing the unknown packets handling. The security alerts are also refreshed every 2 seconds, and they showcase all the unknown packets which are passing through the network traffic. And again, it's upon the user, and this is like show an alert. So if the user has opened an app, and if it's malicious or not. Next, I'll be talking about how is it related to AI native. So first we should know, what does AI native mean. AI native means it's not applied with AI, it is built into the core. So we can confidently say that Aionet is AI native because first and foremost it is cloud independent. And we'll move on to Varsha for the next.
So yeah, here is a common question is that that we get that strikes our mind. This is already existing. What is new in it? It is in the first thing is, this is in the user end. We try to maximize and prioritize based on user's intent, which is not replicated in the routers. So here is the difference between the traditional routers and our Aionet. So the first one is that the traditional routers use static port based rules, but we are using dynamic port based. The second one is that they apply limits or shaping per interface, but we do it for each and every packet. They cannot see the application, the routers do not have information about the application context. Here we our Aionet model, it can classify based on the PID and the destination ports into different applications, like whether it's Zoom or Gmeet or anything. So the next common question we have is, so now let me just try to explain that how the statistic view. So basically, if there is about 1 in 5 user using this, there would be a 10% reduction in the overall network traffic, and then there might be a 35 to 50% or 60% reduction in the user's end during the traffic of network traffic. So this can raise a question: why is why, how can it affect the overall network traffic when each and every router and user is connected using different connections? Here comes the part. There is a backhaul of the route in the backhaul of the routers, everything merged. So this reduction in the user end can reduce significantly the traffic at the routers, by therefore reducing uh, the overall traffic. The comparison is not between routers and Ionet because they both work together. They both have a common part. We can implement the same flow of Ionet into the routers and for satellite, as ma'am said, for dynamic port dynamic port mapping, and dynamically reducing the network traffic, which we aim to give at the user end too. Since it is easy to implement, we have implemented in this. I would like everyone to watch the video, implementation video. Optimizes network traffic in real time with no cloud, no training, and full explainability. INS follows what Gunter says: end-to-end optimization, not chain of blocks. Our AI agent scores and classifies every application in one go using CPU usage, bandwidth, packet behavior, and encryption. The logic is simple, effective, explainable, and fully runs at the edge. We enhance the network by reshaping traffic in real time. AI enables this by assigning dynamic priorities to flows, optimizing what's urgent and delaying what's not. Here we would be able to see that certain things are marked medium and certain are low.
Here's our dashboard. It updates every 2 seconds based on what you can see. Properties which instantly updates species and is stored in our knowledge base. The application layer communicates with the network layer while the AI logic applies scores based on both runtime data and user inputs, enabling a feedback-driven loop. Runtime data and user inputs, enabling a feedback-driven loop. To support emerging applications, Aionet
I
lets
hope
you
it was
create
clearly.
new packet formats. Here, I'm crafting a custom packet.
I hope it was clearly visible that whenever I opened a new application in my laptop, there was a record in the dashboard. So now coming to the knowledge base part. The knowledge base here we are using is an SQL database which she showed. So this has a feedback table. That is where the learning takes place. AI agent learns through the feedback table and it applies it for the future packets of an unknown application.
Packet with 4 custom fields and an 83-byte payload. Now we are clicking on send packet, so the packet is sent into the network. Aionet handles it seamlessly, scores it, logs it, and even reacts to unknown protocols. So yes, we generate and process new packet types. What if an app uses random port, say a malware or misconfigured sync service? Aionet logs it as an unknown signature and infers its priority based on real-time frequency. By light database under security alerts. Thank you. We would like to, if time permits, we would like the judges to watch the videos. And thanks a lot for giving the opportunity. Thank you. Thank you.
Yeah, thank you so much, Team Aionet. Before we open the floor for questions, I request Vishnuji to please explain the evaluation criteria.
Okay, good morning. Yeah, thank you very much. We are getting several questions on the evaluation criteria, so let me just explain from a vendor perspective what is going on here. The template of the presentations that you see on the screen will be exactly same as you saw just now. Every team will present their basic idea. There will be a recorded screen, recorded video, and they will explain that one by one. One specific question has been asked to them to explain to you, that is how this is AI native. This is the template which you will see for all the presentations. Then you see this paper in front of you who are evaluating. Basically what you will see is the sequence of all the demos that you will see today. One by one are here, one by one. This is the sequence that we will follow today. The current set of comments are here. This we have been doing for the last several weeks, few months actually. This set of comments have been very clearly communicated to them. They know these comments, and this is what we have discussed. The main theme of the demo is the first line that you see in this. Each of the team, the main theme is mentioned. So in case you don't know what you don't clearly get, or the team does not communicate clearly, this is the point A, that is the main theme. That's where you read firstly. Then after that, there are certain questions which we have been debating with the team. Yesterday, day before, we had mentoring sessions offline. Before that, we had mentoring sessions online. So these are the questions which we have been discussing with the team. You don't need to worry too much about it. This is just for your information. Then the comments needed from the committee are 1, 2, 3, 4. They are the same for each team. They are the same for each team. These are, you're requested to ask subjective comments, or you can note down here what are your subjective comments. I won't read out here because that is for our own benefit. But basically, if this is for the guidance of the teams, we hope they benefit from your experience and subjective comments what we are asking. The last one is really important, which is they are there related initiatives which they should be pursuing. This will help us as mentors as well to take this forward. Another thing is, next month we are having similar activity in Geneva. It will help us to take some of these initiatives forward in such extensions of this Build-a-Thon going forward. For ITU, this is an ongoing activity. So these, please give subjective guidance. Your experience will be very valuable for the teams. No need to worry about objective part. The guidance and the comments and the questions which you ask will create more value for the teams. For the teams, I am told that many of them are very tensed. I don't think so that is required. I believe we can have just informal demos. I think what we should do is, however, please show a picture, use the time, use the videos, and start with the videos, go through the picture and explanations clearly. You're handpicked, you are the best, no need to worry, no tension. I mean, these guys are very friendly people. All of these are very friendly, very experienced, nothing to worry for the teams. Thank you very much.
Thank you. We forgot to ask, are there any questions left for us from the judges and from the audience? Yes, sir.
Thank you. I just wanted to know whether you have thought that if I manually override all the priorities as high, will it cause any robustness issues? Like if there is something which is medium or low and then I just put everything as high, will it cause any issues?
No, sir. Since this is, based on dynamic bandwidth and dynamic map prioritization, though you can override everything is high, but at the end we follow first come first serve. Like if two priorities are written as high simultaneously, we follow what comes first will go first. So that would avoid conflict and also, can satisfy the user's intent also. Yes, sir. Any other questions? Or
I just have a small doubt only. The way you presented looks like it's more a programmed, not a programmed software or an application. Does not look like an AI agent. What exactly is the AI agent you are talking of? Number one. Number two, will it work on the real time?
Yes,
Then
sir.
how much time lag it will be incorporating into the system? Additional time lag for the particular application.
Yes, sir. So coming to the first question, whether this is AI agent based, and yes, we say it is AI agent based because it is rule based, and we are calculating the heuristics and we are scoring it based on which it is dynamically allotted. And even we also have a JSON file which has all the port rules and other rules which we have. And then based on those it is dynamically allotted, and then we are also learning from it based on the feedback which user gives, and whatever is stored in the feedback data table, we are learning from it also. And coming to the second question about if does it work real time? Yes, it works real time, sir, because we are using Python's SkyPy library, which captures data in real time, and we have also kept the refreshing time and everything so small that it matches with the packet flowing. So if you could watch the video, you will be able to just confirm that it is working real time. Because the moment I open the Spotify, 1 second, I hope I have time to show this. Yes.
Base is SQLite.
1 second.
The feed schema includes app priority back.
1 second, sir. So it's getting logged real time. So when we open the Zoom and then close it, I hope you will be able to see once it comes up. Yes. Yes, sir. Sorry. If we were able to do a live demo here, we'd be able to show it realistically. And then the calculation of CPU and everything, it is done for each packet based on application basis. So I don't think it would take much of a time. Does that clarify your question, or is there any other answer it requires? Yes, sir. Thank you. Any more questions? Yes. Thank you.
Thank you so much.
Thank you so much.
Thank you, team Aionet, for very nice presentation. Now I call Slice Minds for their presentation.
Good morning, dear judges, ladies and gentlemen, all present here. I am Harsh, my mentor Anirban sir. We are from SRM IST Chennai, and we are here to present our idea that we have implemented quite a bit. We enhanced it during the 2-day session as well. So our main idea is to develop a current marketplace that is not there and enhance it in the new coming 5G and 6G era. So our basic flow is if a customer wants a current slice or a network requirement, we want the customer to directly come to our marketplace and can have that specific requirements so it can perform on the specific slice. Currently there is a pipeline of network which does not specify their requirements or understand the purpose of using it. So we define different functions to find the intent of the customer, to understand how the AI will explain why it is using that slice. And through we have considered a flow of our marketplace. So here you can see initially is the client input what he actually wants. So inputs comes from the use case, the JSON files which are in our API documents and goes through the post APIs. These all are the inputs from the JSON with the regions with helping what type of API, what type of slices, what type of different specifications the user wants. How the AI help in this? AI classify the users with 2 or 3 different methods. We started configuring using the 3GPP pipelines. Then we moved to GSMA for increasing the efficiency and the prediction of model more. And currently we have intent-based model also. You can just type what you need and it understand and give you the slices perfectly. These are the client maps that we uses. Currently in the 3GPP we have currently 3 common slices, the EMBB, the URLLC and the MMTC. EMBB used for mostly video watchings using any entertainment purposes. URLLC is used in military, hospitals or very low latency areas. And MMTC is for the IoT services. So current QoS requirements, as you can see, we use the bandwidth, reliability and the location purposes. these are other different device headsets, security levels and priority decks we can give to the clients. Now we can move on to our digital twin feedback.
What you call client registration, sorry, vendor registration.
So yes, here will be the full flow of the slice requirements. The vendor will be deploying in the client onboarding. So vendor will select the slice. As you can see in the document, the slice classifies, the AI classifier will classify the slice. The LLM, based on the scoring, we are using dynamic scoring functions here. We are using different neural network function because rule based will not work here because every user have different requirements according to their functionalities. With the composite mathematical functions, we are trying to dynamically allocate the resources to the vendor deploy slices. Then vendor will send back the feedback to the user and the client can deploy the slice in the system. Currently, these are the key suggested network functions that we are using in our model. So first is the SGTF function, which automate the selection and vendor requirements from the slice and through the vendor APIs. Then we have the vendor slice agent, which assign the slices from the vendor to our marketplace. Same we have the entity and SCDC. It pushes the slides through the UEs into the vendor marketplace, and the entity compliance gives the telemetry of the different slices. Here you can see how the AI agents get the data from the vendor and how it allocates to the different reliability. This is automatic payload function that goes through the slice allocation. Same here, the vendor displays the slices with the different configurations. And here you can see this is the final slice that the user get after the vendor delivery of the deployment slice with the UI.
The configuration
yes.
for
These are all the UE functions and SDC functions.
we have tried to define them for the implementation in 6G scenario so that these can be implemented so that it becomes a AI native function where our functionality can be directly deployable. So if you see that finally in this scenario, so this is the final configuration which the vendor, which the client gets, so that he can configure the UEs and his systems for the particular slice. And from here, deploy slice. So it starts from the vendor side, that the vendor registers itself with its own facilities. We put that also as an input in the in our system, so that the judgment and the capability of the vendor can also be put as a ML machine learning part. When then the client comes into the picture, the client gives its requirement, and in different forms, either it is in a form-based scenario or in an API-based scenario. Even we are taking it as a LLM model, where the client only writes about their use case, and we from the use case we are taking out the requirement or the what kind of slice they will require. We are suggesting that, and then we are putting it to our AIML setup, from where we are deciding that what is the kind of which vendor is suitable for this, because we have already taken the vendor capability input before when the vendor has registered. So depending on that, we give 2 to 3 options for the client. The client selects that particular slice, and then we deploy that slice. We have that's why we have created a function only, so that direct deployment from the marketplace to the vendor API call can be there, and vendor directly deploys that slice and gives the configuration back to the marketplace, which is again given to the user side, the client, so that the client can implement the UE functionality. And then the entity is the backside, where we are also monitoring the functionalities and the scenario for that particular slice, health of the particular slice, and depending on that, we are also increasing, decreasing, or manipulating the scoring accordingly, because for the future use cases, and even that we have not yet implemented, but warnings and all also can be initiated from the marketplace if the specification of the SLAs which are been promised is not delivered properly.
Yes, so I will show a quick demo of our marketplace. Here you will be able to see a AI prompt box. The prompt box is to identify the intent of the user. So if a user doesn't want to identify what slice it wants, he doesn't need to know. He can just directly put his use case and we get the thing from there. So currently we talk about the data, how our model is trained and how it is very efficient. So if you can see, these are the data points we have used. So I think it is visible. All the timestamps, traffic data, load hours, how much traffic is there, optimization slices, current slices, what slices using in which format. This is the data visualization graph for over different slices, different traffic simulations and different activations. And this is our LSTM model which is we are using for configuration and monitoring our slice functions. So you can see there are 200 points which are forecasting and which are getting high and low peaks in the model direction. So we will show the current demo functions, like a user just said, I want to run my autonomous vehicle to our marketplace. We will allocate a URLLC slice for the lowest latency. Our model finds the intent from the sentence and allocate the correct slice to the user. It goes directly to the step 3 because step 1 is step 2 is under the 3GPP guideline to understand what slice the user wants. But from an intent, we can identify that as well. So the AI will process completely, it will give it a score and it will score all the current vendors that are available in the marketplace. We have shown how the score is calculated as well. Like this, this is a neural network we are using. The neural network will identify the dynamically importance of the system. So we have the weights. The weights understand the concurrency of the data and the concurrency finalize the score of the current user. Accordingly, we find the best vendor and it will be deployed in the model. So these will be the deployment configuration for the customer, which he can be deployed in their system correctly. Here the QS metrics and the monitoring parts come in. We are using a LLM based agent and a MCP server. So we are taking the context from the internet as well as from the system of the user, where the user identifies if any problem in the current slices are occurring. So if you can see the Gemini analyze and the context 7 analyzes, the URLLC part is correct or not. Optimization results will be also provided to the vendor side so they can improve their slices as well. So it should be considered as a end-to-end system. We try to solve our black box nature of the AI problem, which the AI doesn't explain why it is not working correctly. So we try to implement that part using our MCP server and LLM agents. Then we have the domain knowledge integration, where we use the domain of the user and the vendors to integrate the knowledge and give the correct results with mathematical and composite AI model functions. And at last, we are kind of proposing 3 functions here. First is the AIMF function, which is the AI intent mapping function, where AI will have the intent to map different type of functionalities from the marketplace or from any kind of systems. The second function is SVSF. So it is the slice vendor score function, where we don't use rule-based function like currently we use in the EC or telecom market. We try to make it dynamic because every time user doesn't need every slice or every possible vendor they want. We want to make it dynamic. So we initialize that function that can be used in anywhere in the native part as well. The third function is the trust and SLA scoring function, which help us to identify what trust and how the scoring will work in the market scenario. So currently we have these, and for the 6G market scenario, we have some.
Yeah, so these are the proposed scenarios for AI native which we are trying to do. As he has mentioned few, AIMF we have it converts the service level. So these are all definitions which we have given in the document, which we think we can work around. And then at a management and orchestration level also we have some suggestions which are there. We have used different parts for that in our use case, and we think that if these are a part of the AI native scenario, then definitely we can have a better working of our model. And definitely marketplaces for 6G is slice marketplaces for 6G will be a very common thing anyway. So I will just show the so the strategic justification we are putting up, that it aligns with the design philosophy. It's an intent-driven, dynamic, SLA assured, policy compliant slice network slicing. So this is our main pitch line which we are putting up, and it is an operator control function to ecosystem marketplace. So ecosystem marketplace functionalities are not available currently in any form, but as we can see that slicing and selling the slices in a particular way will become a big part of 6G. So these functions we have tried to implement, orchestrated in some parts. Some parts we have just imagined it and done some simulation, but this is what so we have tried to write down most of the things that what we think that which should be there. Thank you.
Clarification questions?
I'm here. I have one question. Thank you for the presentation. The question is a little bit of a challenge. Imagine that we want to take your software, your demo, and we want to put it into a production network, in a real network. You didn't explain exactly how would you assume to be training the model. So before the system is actually capable of identifying the proper slice according to the requirement. And
so we are using a historical data setup here,
yes,
which we are training. So we have some synthetic data currently with us, which is because see each of the defined setups which are there, they all have their own limitations in the system. So depending on that limitation only, and from the context which we are taking out, we are mapping these two things out and creating it.
So it would be based on probably a database or records from the operator who wants to implement
yes,
your...
so sir, if you can see in the screen, can we show the screen?
I cannot do anything, I'm just talking.
Okay. So we are using a LSTM model, that is an auto-regressive LSTM model which has the entity feedback loop. It controls from the user side and on the historical data as well. So we predict if you are using correctly and forecast as well. So then we compare it with the forecast scenario, and then we use mathematical equations to identify if it is correct or not. Basically a decision tree we will make. So, and for the production part, it is a compliant system that we can use for the production as well. From the network layer, it should be connected to the vendor department, and it should go to the client-side server through the JSON format currently.
Anirbanji, I think to answer Ricardo's question, you should probably go back to the Open 5GS and the lab that we discussed.
Yeah. So sir, we have tried that part also.
Simulated
that,
Open
we have
5GS.
simulated a basic scenario where we are using 3 core Open 5GS core setup in container lab, and we are creating different user scenarios where we are getting each slice giving around 3 to 4 pairing up. But we cannot show it in the demo we discussed yesterday because it's all the black screens. Okay, so we have not done that. So that part we are doing. So in that we are trying to create some apps in between, and those apps only we want it as a functionality which should be there, so that it becomes a AI system.
So still we are creating different functionality to get it actually native inside functionality. If not the marketplace, we can use function in different areas.
Because these functions are very common for slicing as a scenario also. It's not only
the marketplace
scenario, these are common functions which we see.
Thank you. Any more questions?
Hi team, very good presentation. I have just one question. Suppose if some URLLC operation is going on, remote surgery is going on, and a slice you have recommended, then suppose the SLA is not met in between, will your software change the slice?
So that is, we are not the owner of the core setup, so we are not the vendor. So what we can do is we can reduce the scoring of the vendor for that time, and we can have the alarm system that we have implemented, but we are not controlling the slicing or slicing activity. We are a monitoring setup, and definitely that vendor will have a very low score in that kind of a specific kind of a slice option for the next time. That we can assure. We cannot. We can have safeguards like this, but we had a thought that we can do something that we can have 1 or 2, depending on the priority of the setup, that we can have 2 slices, one as a backup slice which we can init, but we have not yet thought of that.
But suppose if you take up a backup slice sort of thing, will not it take some time for the network configuration?
Definitely.
So actually we have implemented a fallout system as well. So if our marketplace doesn't allow, or if because of some technical issue the slice did not get allocated, so current slice of vendor will extended the time till the slice will get allocated, and it will fall back to the rule-based system that is currently working. So the network doesn't go anywhere till our slice will not deploy it.
One suggestion, can we limit the number of users on a slice from vendor perspective also, so that a load balancing sort of done?
Sir, we can have this as a monitoring part where we can, because it depends on the vendor, how much vendor will allow us to work it around it. Definitely, that's a good thought. That the monitoring part, and we can have some control over it. We have not gone into the control angle that much for the.
We are trying to develop the dynamic functions as well to deploy the bandwidth differently. I remember you asked yesterday the same question on the bandwidth. So we are trying to deploy a dynamic function which differentiate the bandwidth between different users. So we will try to do that as well.
Okay, thank you.
But the implementation we have to see that how the vendor will give us the, because we want to work like first as a marketplace so that we have all the control on the result and ranking scenario rather than directly on the operations. But definitely some operation functions can be put into so that we can make more assurance that the whatever criteria is given is maintained.
Yeah, that would be a more approach toward AI native, when it will be self-configurable and self-autonomous sort of system.
Yeah. So, but on that part, I will say that we assume that that part is more taken care by the vendor itself, not by us. Because then we are getting into the vendor's role.
It should be into the core of
we are more into the monitoring part rather than the operations.
Yeah, I think Dhaneshji's question is important. You should probably take it down and perhaps take it as the next step. I think, like you are saying, monitoring may be the way to handle it from your side.
But definitely we should have some control over it because we are the face, because people are coming to us, not to the direct vendor.
But monitoring control loops, closed loops, actually, that may be the first step to handle Dhaneshji's question. And also, I think your self-healing, the real-time self-healing that he is asking, that's an important part.
Yeah, that we can, because we can work between multiple vendors to give a second option. It's like how your Ola Uber breaks down and they give you a second car. So something like that we can definitely, we are already looking into. Thank you.
Thank you so much for the telecommunication department for the opportunity. Thank you for the Buildathon.
Thank you.
Thank you, Team Slice Minds. Now we will take a break. Let's meet again at 11:30 IST.
Recording
that is
stopped.
in 22 minutes.